So what about the software? Your question earlier is extremely valid because data scientists don't know hardware at all. They've got to run these jobs. They have no clue what this entails. And when you talk about all of the things that go into deploying the system, data scientists do not want to deal with that. So that's where the software stack comes in. We start out with bare metal provisioning. That's probably a multi-hour job. Once you provision the nodes, which is GPU compute management provisioning, we've got the compute nodes being automated with DPops. So DPops, which is the NVIDIA software, runs through, it deploys a Kubernetes cluster on the management node, deploys the basic services across the management nodes, provisions the compute nodes, deploys additional services, and is now set up to a point where you can start running these jobs, which is where we come in with the AI control plane.
So wait a minute. Can you go back to the previous slide?
Sure.
So this is deploying your solution, your NetApp solution.
So this is bringing up the cluster for the first time. So you've racked and stacked the ONTAP AI compute and network and storage. You have automated the deployment of software for the first time. This is a one-time setup.
And so you guys are seeing that your customers have settled on Kubernetes and that's what they're running versus running their own custom in-house scripts?
Yes.
That's different than what I've seen.
So from an AI perspective, Kubernetes is certainly becoming the de facto choice. You'll certainly see some Slurm. There's certainly Slurm usage. If you're coming at it from an HPC background, Slurm is very much the de facto. And you'll see engines like Bright Computing with Slurm that is being used. It really comes back to, is this team coming from an HPC background, or are they coming at it from a AI out of grad school, doing their AI doctorates, and they're now looking at Kubernetes and Kubeflow. So it's two different.
Okay, but but an AI architecture is usually backed up. Everything you just talked about was machine learning. So really, it is an HPC type of architecture. So, and it's fine if that's what you're seeing most of your customers doing is Kubernetes, but it is really an HPC architecture.
Yeah, we actually think it is a variant of HPC. We actually don't think it is HPC because you see a lot of random small file reads. So the place where we can look at this as HPC is if you're doing a workload that is very large video-based AI, so video feeds, for example. But if you're doing computer vision and even NLP, these are random image reads where the size of the image is much smaller than your typical HPC workload. A typical HPC workload is sequential, parallel reads of massive files.
But what you were just describing was machine learning and deep learning, and those are definitely based on HPC architectures.
So we've seen customers go through that journey where they've started out with an HPC system and eventually reach the conclusion that HPC is not giving them the performance that they need, and they're starting out with ground-up architectures that are moving away from HPC. So this has happened over and over again, where they may start with a GPFS or a Lustre parallel file system, and then realize that you're getting opens and closes, and the overheads of opens and closes, the metadata overheads, the random read overheads, and the frequency of checkpoints alongside with the reads. All of that changes the workload to be different from HPC.
Yeah, the transition is from compute to data.
I agree.
Yeah, I can't name the number of places where we've seen that realization and say, okay, we've got to rebuild this thing. It's not just our old HPC infrastructure. So,
but we are seeing that GPFS is not good at handling small files. We are not seeing that this is not HPC. I mean, there are several HPC workloads that are based on small files. It's just that you have to choose the right file system in most of the cases. It's not just that it's not HPC. I mean,
in fact, what I've seen as well is in most of the cases, some of the organizations go with GPFS because it's been here for a long time, because it's the only thing they know, and because it gives them the assurance that it's going to work. But there's a lot of storage systems out of there which are good for HPC as well. Which are much more efficient.
Yeah, it absolutely comes down to where the team is coming from. If the team's coming from a background where they've been used to GPFS, they're going to start there. And in some cases, they're going to revisit it. In many cases, they look at what is the overall architecture. It's not just training in isolation, but it is how do you build that control plane as we go into the next view here across the pipeline. And when you talk about the control plane across the pipeline, you're now looking at the movement of data through the pipeline. So it's not just about the GPFS or Lustre parallel file system, but it is what are you going to deploy in the cloud?
Why do you need something in the cloud? Because you keep saying that too, and the data is not in the cloud. So like, this seems like a very specific problem or application that you've built or that you're building. So like, why do you keep going to the cloud? Do you really think that anyone that does AI is going to have a cloud presence as well?
Yeah, that's a great question. So what we've seen is startups that are innovating in AI, data labeling. I'll take one simple example. Data labeling startups that are building semi-autonomous labeling software are building it as cloud native. So if you need to get data labeling
But
on
what
your
cloud
data
are they using? Because when did GPUs and things to actually do deep learning, and how long has that actually been available in the public clouds?
So GPUs have been around for about 6 or 7 years when you go
But
back.
not in AWS. They've
No,
not been
2-3
available.
years.
Yeah. Okay.
So
But anyway, it's not a problem. So when you start a new machine learning project or deep learning, you choose your architecture. And for some companies, the least, the smaller of the problems is the infrastructure. I mean, there are so many layers on top, special business objectives, that you don't really care if you're spending money on the cloud for that. I mean,
The trick for startups is they're optimized to fail.
yeah,
Right?
So they don't really
Whether it's
care
right or
about
not,
it.
you stick it in the cloud because
the-
you're going to
The problem then comes if it becomes strategic and you have several
Yeah.
projects on it, and you say, oh wow, this is becoming
Yeah.
very
Well, the thing is,
expensive.
if you're an investor in a startup who's doing some AI, like doing some data labeling, which is big business, you want to give them $5 million, but you don't want them spending $5 million on a NetApp AI cluster.
Oh yes.
And then there's nothing. There's no money left for anything else, right? So they start in the cloud, and then they fail in the cloud, and there's nothing to clean up. There's no assets to disperse or to dispose of,
Exactly.
or to clean, whatever, right? So the cloud is optimized for startups to fail in this area. The cloud AI processing is incredibly slow. The data rates that you get to and from the data lake is very slow. It takes 10, 50, 100 times longer for the AI to finish if you're running it in the
Oh
cloud.
yeah, but
and it's-
people that are building very large, all the automotive companies, they are building their own AI farm. I mean, but they are used to build their own HPC farms as well. So they have teams working on it since
Generally,
forever.
It's more sense to do.
It's
The problem
it's-
here is that these are data computers, not compute computers. The transition that you're seeing in AI is that you're no longer worried about the CPU. Your primary concern is the data and how you feed it into the GPUs.
Yes, so that you need a throughput that is highly.
The throughput.
And,
Yeah,
and
the
so
throughput
on that note, what I'm gonna sort of segue into is you're dealing with a variety of dimensions. You've got the data scientists who want to just get started. They don't want to wait on hardware. They don't want to pay for hardware, much less deal with the time that you need to deploy. So they go into the cloud because they can start right now. Their software, whether it be data labeling, whether it be inferencing, version management, whether it be the pipeline automation, these are software from startups that are being cloud native at first, at least. And so the cloud is absolutely seen when you're dealing with this life cycle for experimentation. As you get into production, the cost, the performance, the linear scalability, all of that brings it right back to on-prem. So when we go back to what is the NetApp AI control plane, we talked about the one-time deployment automation with Ansible. And then we get into the ability to deploy with Kubernetes and Kubeflow. So we've integrated ONTAP with Kubeflow, where we are now able to deploy and manage the lifecycle of a Kubeflow job through the Trident storage plugins and the backend lifecycle management of storage. So what does that mean? If you're starting out deploying a Kubernetes cluster, the first thing we do is we deploy a Trident storage plugin, which is the backend to manage storage on an ONTAP system or a NetApp system in general. The Trident plugin integrates into Kubernetes and claims the persistent volume interface so that when you start to provision storage, you're now provisioning storage from a NetApp system. So as you build out these Kubernetes clusters, data for the underlying system is being provisioned out of network storage. And that network storage, coupled with the compute stack, can be replicated across sites, whether it be in the cloud, whether it be other sites, whether it be at the edge. So as you build out these Kubernetes clusters, we've got the identical software stack, compute and storage, now federated using the data fabric, allowing you to start a cluster up and burst into the cloud, start in the cloud, and burst or reverse burst on premises, and go in both directions. So let's talk about some use cases. The data scientist started out in the cloud. Once he was done with experimenting and the hardware was provisioned, he can reverse burst on premises and spin up the job in production. The data scientist started in the cloud. He can reverse burst across sites. If you've got data science at corporate headquarters, production is across the different sites for the company. Now we are talking about reverse bursting into each site to run at those locations. Similarly, if you're retail, for example, you need capacity in the holiday season. You start out a job that's running on premises. You might get some additional capacity expanding out into the cloud. Kubeflow is becoming the standard or the de facto for managing the SDK for AI.
In the previous slides, are you saying that you start working on the cloud and then you move all your data set back on premises?
The small subset of data that was used for experimentation. So you don't want to look at this as, if you go too deep into deploying in the cloud,
okay, you're stuck there.
now you're stuck.
Okay.
But if you are in experimentation stage, you've got a data scientist doing small experiments, hopefully you're dealing with 10 to 20 terabytes of data.
Okay. I have to say that if you need to more 10 to 20 terabytes, there is no difference on the architecture you're using. But, it's nice to have if you have NetApp, but if I have anything else, it works anyway.
So where you start with the experiment is 10 to 20 terabytes. As you start to scale into production, now you're talking 100, 500 terabytes, a petabyte, and that thing takes a life of its own as you start to expand.
No,
So
but we're starting talking about moving 10 terabytes.
Yeah.
So 10 terabytes is 10 terabytes. So I start working in the cloud, and then I choose an architecture for my own premises. They could be totally different. I mean, I do not want to plan in advance the architecture that I will use on my premises anyway. So I start to experiment. I decide that AI becomes strategic. Then I choose a partner for my, and maybe NetApp is cool for a reason, and I go with NetApp. But actually, potentially, I started working on Microsoft Azure or whatever, and I didn't choose NetApp to start with because there is VXFS from
and hopefully you started on Azure NetApp files because that gives you some level of commonality. So there are some options with CVS and Azure NetApp files.
If I'm not a NetApp customer, I mean,
So
you need to have a very, very long-term strategy for these kind of things to think about. I start with NetApp because I will buy NetApp on premises. Because if you're talking about buying millions of euros of infrastructure, there is everybody.
So we are building data movers.
Table.
So we're building data movers to go from object into NFS. So we're moving data from S3 to NFS. We're building data movers from GPFS and Lustre to NFS.
Are they ready?
Yes. We've got POCs ongoing with customers to move from MapRFS to NFS. So the data mover is the key ingredient because you're right. There's all kinds of data sources. And it's not enough to just say everything's got to be an NFS. It's not going to be an NFS. So we are building data movers across every data source and adding as we go. So today we've got HDFS, MapRFS, GPFS, and S3. And we're going to keep expanding that list. And we're building POCs. We are sizing the data movers. We're optimizing the data movers to do parallel data movement. So these are things we have today. Absolutely building that. So this is where you end up. Kubeflow as the SDK, provisioning a Jupyter notebook for customers. So you end up with a Jupyter notebook per data scientist, provisioned under the Kubeflow SDK, and Kubeflow under the covers using Kubernetes integrated with Trident, provisioning storage out of the NetApp data fabric, whether it be in the cloud, whether it be on premises. being able to take you from one location to the other to burst, reverse burst, or expand. And so here's what this stack eventually ends up like. You've got a data scientist workspace, which is a Jupyter notebook, integrated and offered through the Kubeflow SDK, connecting into data through our Trident persistent storage plugins, built and deployed using Kubernetes clusters across a variety of GPU nodes, on-prem or in the cloud.